For more problems and videos like this for linear algebra, you can take a look at Sarai Studies. Link is in the description box below. Another question that they like to ask you is they give you a vector and they ask you if it's in the column space of A. All you're really doing is if this is your resulting vector, you're just going to treat this as an augmented matrix and then plug that in, put it in a reduced row echelon form, and make sure there's a solution. Because your question is it possible to have this matrix give me this result? So in other words, you just want to know if there's a solution to this system where this is your matrix and this is your result. So we just have to put in a reduced row echelon form, but remember that reduced row echelon form is ZO plus 1C. So this is row echelon form. All 0 rows are at the bottom of the coefficient matrix. Remember, when we're checking conditions for reduced row echelon form or echelon form, we're only looking at the coefficient matrix A, not A of B, so we don't include these values. Are all 0 rows at the bottom of the coefficient matrix? Yes. Does it pass the staircase hack? Well, identify your leading entries. Here, I skip until I get to a number that's not 0. Here, I skip until I get to a number that's not 0. And then here, there's no leading entries. So these here are my leading entries. So I start at my first one and I keep going until I reach my second leading entry, and then I just keep going. The height of each step is 1, so it passes the staircase hack because we don't want a staircase that looks like this. This is too steep. If you take a step, you're gonna die. So it passes the staircase, and then all of the entries under your leading entries should be 0. Are they 0? Yes, yes, yes. Beautiful. So it is in row echelon form because it passes ZO. But let's see if it's in reduced row echelon form. Are all leading entries 1s? Yes, yes. Are they the only ones in their column? Well, this is the only one in this column. This is the only one in this column. And by 1, I don't mean the number 1. I mean that they're the actual only number other than 0 in its columns. So it is in reduced row echelon form. So ideally, for any of these vectors that they give me, all I have to do is just plug it in right here. So this would be 2, 1, 0, and this would be 1, 0, 0, and just make some conclusions about it. For example, here I see 0 is equal to 1. That's not true. So that means that there's no solution for the system, meaning that there's no possible x variables that will combine with these vectors to give you this vector u, or in our formula b. So no, this vector u is not in the column space of A. What about this one? Well, here we see 0 is equal to 0, so to me that tells me that there's many solutions. That means that there are multiple x1, x2, x3, x4 variables that will combine with these vectors to give me this vector w. So therefore there is a solution. There's many solutions actually. So this vector is in the column space of A. And then here I see the exact same thing. 0 is equal to 0, that means there's many solutions. And for the same reasons as above, this vector k is in the column space of A. And that's it for this video. I'll see you in the next.